Good morning, sir. I am Homera Banu from CSE department. Today I am sharing a video presentation on the topic Principle and Applications of IR Spectroscopy. The outline of my topic is Introduction, Infrared Region, Principle, Applications and Limitations. Let's starting with the introduction. Infrared spectroscopy is the spectroscopy that deals with infrared region of electromagnetic spectrum. That is the light with longer wavelength and lower frequency than the visible light. Going to the definition, it is the study of interaction between infrared light and matter. This process is based on the absorption spectroscopy. Now, history. It was discovered by Sir William Herschel in 1800. It is used to study and identify chemical substances or functional groups in solid, liquid, or gaseous forms. It is very sensitive to determine of functional groups within the sample, since different functional groups absorb different frequency of IR spectrum. And IR spectroscopy can be visualized in a graph of infrared light absorbance on the vertical axis, which is the y-axis, versus frequency or wave number or wavelength on the horizontal axis, that is the x-axis. As we can see here, an example of the graph. Here we have placed a wave number on the x-axis and the transmittance on the y-axis. It is an example of 1 hexanol. The method or technique of infrared spectroscopy is conducted with an instrument called the infrared spectrometer or spectrophotometer, which produces an infrared spectrum. Now, infrared region. IR spectroscopy is also classified into three regions because of the characteristic properties in different regions of IR. Here telling that is IR spectroscopy is classified into three types. They are far infrared region, middle infrared region and the near infrared region. Let's going with the far infrared region. Its range is from 400 to 33 centimeter inwards. Vibrational of molecules that containing heavy atoms, molecular skeletal vibrations and crystal lattice vibrations. The second one is middle infrared region. Its range is from 4000 to 400 centimeter inwards. It's useful for the organic analysis. The third one is the near infrared region. Its range is from 12,820 to 4,000 centimeter inwards. Overtones very useful for quantitative analysis. Coming from the principle, IR spectroscopy is concerned with the study of absorption of infrared radiation, which causes a vibrational transition in a molecule. As it causes the vibrational transition in a molecule, it is also known as the vibrational spectroscopy. Infrared spectroscopy exploits the fact that molecules absorb frequencies that are characteristics of their structure. These absorptions occur at resonant frequencies. Resonant frequencies means the frequencies of absorbed radiation matches the vibrational frequency. IR spectroscopy involves transition between vibrational energy levels of a molecule. These transitions takes place by absorbing the IR spectroscopy falling in the region 500 to 4000 centimeter inwards. According to the principle of IR spectroscopy, if a molecule is exposed to infrared radiation that matches the frequency of one of its vibrational mode, it will in most cases absorb energy from the radiation and jump into the higher vibrational energy state. The difference in energy between the two vibrational states is equal to the energy associated with the wavelength of radiation that was absorbed. Some bonds absorb infrared light more strongly than others, and some bonds do not absorb at all. In order for a vibrational mode to absorb infrared light, it must result in a periodic change in the dipole moment of the molecules. For example, as we go to the molecules like HCl, H2O, CH3Cl, there is a dipole moment change. Thus, they are called as the vibrational active molecules. Whereas we go for the molecules C2H2, C2H4, it does not change the dipole moment. Therefore, they are called as vibrationally inactive molecules. Now going to the applications. As we discussed earlier, it is used to identify the functional groups. IR is crucial for identifying functional groups in organic compounds, aiding in structure determination. Next one is quality control. They are used in pharmaceuticals, polymers, and other industries to ensure the product consistency. Forensic analysis. They are used in forensic labs to trace the evidence and identifying substance in criminal investigations. Environmental monitoring detects pollutants and monitors the atmospheric components. Food analysis. It is not only used to no, it is not only used to find the quality but also used for identifying components like fats, proteins, and carbohydrates. Material science, analyzing polymers, ceramics, and other materials for research and development. These applications showcase the versatility of IR spectroscopy in various scientific and industrial fields. Coming to the fingerprint region, absorption band in the region 1500 to 500 centimeter inverse. Useful for establishing the identity of a compound. It consists of again three regions. The region with 1500 to 1350 centimeter inverse. Appearance of double near 1380 to 1365 centimeter inverse shows the presence of tertiary butyl group, and the region with 1350 to 1000 centimeter inverse, it is used to show the absorbance in the region due to C carbon oxygen stretching, the components like alcohol, esters, lactones, etc. And the region below 1000 centimeter inverse. This region distinguishes between cis and trans alkenes. And the last one is the limitations. We have some limitations for IR spectroscopy, and they are it is not possible to know the molecular weight of a substance. And the second is it does not provide any information of the relative positions of a different functional groups on a molecule. For a single IR spectrum of an unknown substance, it is not possible to know whether it is a pure component or a mixture of components. Thank you, sir, for listening to my video presentation.